Section 7.6 of your textbook covers the topic of systems of linear inequalities. The solution set of a system of inequalities is the set of all points that are solutions of all individual inequalities within the system. And to graph this solution set, we will first graph the solutions of each inequality on the same coordinate plane. Next, we'll indicate the solutions of the system by identifying the region where the shaded portions of the graphs overlap. And finally, we'll label all corner points of the region containing the solution set. Let's look at some examples. In our first example, inequality number 1 is x plus y is less than or equal to 1. We'll graph the solutions of that inequality in red. And inequality number 2 is x minus y is less than 5. We'll graph the solutions of that inequality in blue. The boundary line for the first inequality is the line x plus y equals 1. This line has an x-intercept of 1, 0, and a y-intercept of 0, 1. Because we have a less than or equal to sign, we'll use a solid red line to graph our boundary line. Now we need to test a point in order to determine which side of the boundary line should be shaded. Testing the origin, if x is 0 and y is 0, we obtain the inequality 0 is less than or equal to 1. Since that inequality is true, the origin is a solution, as are all the points on the same side of the boundary line as the origin, so we shade them red. Now turning our attention to the second inequality, the boundary line is x minus y equals 5. This line has an x-intercept of 5, 0, and a y-intercept of 0, negative 5. Since we have a less than sign, our boundary line will be graphed as a dotted blue line. Once again, the origin is a convenient test point. If we substitute into our second inequality, we obtain 0 is less than 5, which is true. So the origin is a solution of this inequality as well, as are all the other points on that side of the blue boundary line. Now we can see the region of the graph where the points are shaded both red and blue, representing the solutions of our system, because these points are solutions of both inequalities in the system. The corner point of our solution set is the point 3, negative 2, which we can see on the graph, and we label with an open circle because of the fact that it is not a solution of the system. The corner point is a solution of the first inequality because it lies on the solid line, but it is not a solution of the second inequality because of the dotted line. If we have trouble identifying the coordinates of the corner point from the graph, we can also obtain those coordinates by solving the system of equations for the boundary lines. So if we solve the system by elimination, we can add the equations and find x equals 3, and then we can substitute back into equation number 1 to find y equals negative 2, thus identifying the corner point algebraically as the point 3, negative 2. Let's move to another example. Again, we'll graph our first inequality's solutions in red. In this case, the boundary line is y equals 2/3 x minus 1. This is a line having a y-intercept of 0, negative 1, and a slope of 2/3. So we can find more points by using a rise of 2 and a run of 3. And we see a less than sign, so we will use a dashed red line for our boundary line. Using the origin as a test point, we would obtain 0 is less than negative 1, which is a false statement. Therefore, the origin is not a solution, and the points that are solutions lie on the other side of our boundary line and are shaded red. Turning to inequality number 2, we can solve this inequality for y by first subtracting 3x on both sides, and then dividing both sides by -2, remembering to reverse the direction of the inequality symbol because we divided both sides of the inequality by a negative number. So our boundary line is y equals 3 over 2x minus 2. This line has a y-intercept of 0, -2, and a slope of 3 over 2. So we can use the slope to find more points. And then once again, we will use a dashed line, in this case because we have a greater than symbol. Testing the origin, we would obtain 0 is greater than -2. This is a true inequality, so we want to shade all the points on the same side of our blue boundary line as the origin. And now we can see a region in between the two boundary lines, which I will shade green, indicating the solutions of our system, those points that are solutions of both inequalities. Once again, our corner point would be indicated with an open circle because it is not a solution of the system. And to find the coordinates of the corner points, we can solve the system of the boundary line equations. In this case, y equals 2/3 x minus 1 and y equals 3 over 2 x minus 2. Using the substitution method, we can then clear the fractions by multiplying both sides of the equation by 6. Then we can add 12 on both sides and subtract 4x on both sides in order to obtain x equals 6/5. Now solving for y, in equation 1, we have y equals 2/3 times 6/5 minus 1. Finding a common denominator, we obtain y equals -3/15 or -1/5. Therefore, the coordinates of our corner point are 6/5, -1/5. Let's look at one final example. In this case, we have a system of 3 inequalities. Inequality number 1 is y is greater than or equal to x. So our boundary line would be y equals x. That's a line that passes through the origin and has a slope of 1. We will use a solid red line to graph the boundary line because we have a greater than or equal to symbol. In this case, since the line passes through the origin, we cannot use that point as our test point, but we could test a point such as 0, 1. If y is 1 and x is 0, we obtain a true inequality. 1 is greater than or equal to 0. So all the points on that side of our boundary line should be solutions. Turning to inequality number 2, y is less than or equal to 3. The boundary line in this case is the horizontal line, y equals 3. And once again, it will be a solid line. The origin, since y would be 0 in that case, would be a solution. So we want to shade all the points below our blue boundary line. Finally, our third inequality, we'll use black to represent its solutions. X is greater than or equal to -2. The boundary line would be x equals -2, which is a vertical line. And once again, it will be a solid line. And since we want points that have x coordinates greater than or equal to -2, we will shade all the points to the right of that boundary line, including the origin. In this case, the solution set for our inequality would be all the points contained in this triangular region that is shaded both red, blue, and black. So to make that more clear, we'll shade it green. And then we'll label our corner points. In this case, because we have solid boundary lines, our corner points will be closed circles. And the coordinates are readily identifiable from the graph as the point 3, 3, the point -2, 3, and the point -2, -2.